In this example, we are going to use the kinematics model to analyze a problem involving vertical motion. So in this example, we're going to take an example of an object that's thrown upwards from a cliff. And I'm going to throw it upwards at a velocity of 3 meters per second. And this is a pretty big cliff, but it's going to go up and it's going to come back down. And we want to know what the velocity is when it travels 200 meters down from the top of the cliff here. Now notice this is up and down motion. We're not going to throw it outwards. That would be the 2D kinematics model, which we'll deal with later. Right now we're just going to talk about vertical motion, straight up and down. So this is a kinematics model in the vertical direction, and what we're going to actually be looking for in this problem is the velocity at this 200 meter mark. We call it Vy, the velocity in the y direction, and B, we want to find out how long it actually takes for it to do this. So this is a kinematics model problem, so we're going to follow the same 3 steps we did before in the first example, except since this is up and down motion, we're going to use the variables y instead of x. So y equals y0 plus vy0 t. Again, that subscript 0 means at time equals 0, plus 1/2, and we're going to use a special acceleration, the gravitational acceleration, which is g, which has a specific value. Vy is equal to vy0 plus gt. So wherever we had a before, we're going to use the special acceleration g. Vy squared is equal to vy0 squared plus 2gy minus y0. Now the key to doing these problems is the following. We're going to put an xy axis, we're going to overlay an xy axis right on the problem, right where the motion begins or originates from. Hence the word origin right there. So wherever the object begins, we put the xy axis, and so there you can see the y axis. And this is really important because we're going to make measurements relative to this axis. Vectors are going to be denoted as positive or negative depending on this axis. So this is really, really important. So draw that on the given. The next step, list the variables. So same thing we did before. We're going to have my initial displacement, my final displacement, y, my initial velocity, vy0 at time equals 0, vy. Acceleration is the special one, g, and time. And we go through, and again, this is the physics of the problem. If we can list these variables correctly for the problem, then step 3 is just the mathematics. So let's go step by step. Initially, my initial displacement, since I put the origin right here where the motion begins, that is 0. In other words, if that was the y coordinate in math class, you'd put 0. So it's 0 meters. My final displacement down here is below the axis. So even though we say 200 because we just say that in English, a physicist would say more specifically minus 200 meters because it's below the axis. If we had plus 200, that would actually imply a point above the axis. So this allows us to differentiate points above or below the axis. My initial velocity is 3 meters per second because I threw it upwards. Little side note here, if I had dropped this, just dropped it, it would be 0 meters per second starting from rest. Or if I had thrown it downwards, because this is the negative direction, that would be minus 3. So I can actually account for throwing things upwards, dropping them, or actually throwing them downwards. My final velocity, which is a vector that points downwards right here, because it's moving downwards. I don't know. I do know that it's negative though. Negative so many meters per second. So I'll put a box here because I don't know what it is. The acceleration due to gravity is negative 9.8 meters per second squared. It's a vector quantity and it actually points down. That's why things fall downwards. And the time, I do not know how long it takes. We're not given that. So So far in the problem, what I've done is I've key point overlaid the XY axis on the problem at the origin, where the motion originates from. I've listed my equations, I've listed my variables, and now we're just going to do the solve part, which is the mathematics. So for the final velocity here, or the velocity at this 200 meter mark, what I usually do is I look at what I don't have. I don't have time, so that's a variable. I don't have time here. I don't have velocity, my final velocities. And let's see, that's 0. So, looking at my equations here, this equation has Vy, but there are two unknowns, so that's not a good one. I actually could find time here first and then plug it in there, but actually I see that I can go to this equation. I have everything except that Vy, so I'll just use that one. So if I go over here, Vy squared is equal to Vy0 squared plus 2G y minus y0. So I have everything there. So I plug in the numbers, I get 3 squared plus 2 times negative 9.8 times negative 200 minus 0. And that's Vy squared. Now if I want Vy, I square root both sides, like that. And if you calculate this, I get the value of 62.6 meters per second. That's Vy. With one small detail. I initially thought that velocity is negative, which it is because it is going downwards. But how do I get the negative here? Well, remember when you take square roots, there's actually a plus and minus root. So we're going to select the minus root, which gives us the negative value. So there's my answer there for velocity. B, how long does this take? Well, I could use the first equation because that's the only unknown, and I'd have to actually use the quadratic formula. Now that I know Vy, this one looks a little bit easier because it only involves t and not t squared. So I'm going to use this version right here. So t is equal to, if I solve for t algebraically, is Vy minus Vy0 over g. So what I did was I brought the Vy0 over, made it negative, and divided by g. That's some algebra there, and so then I get negative 62.6 minus, what's Vy? It's 3 all over negative 9.8, which I get a value of 6 point, this is an 8 here, 6.7 seconds. And you can see the importance of that negative sign here, because if I didn't have that, I'd get a negative time, which would not be good. So there's the time, 6.7 seconds. So it's the time for it to actually go up, stop, and come all the way back down. And at that time, the velocity is negative 62.6 meters per second, going pretty fast, because gravity acts on it for a long time. So the key points in this problem are, number one, overlay the XY axis at the origin where the motion begins. Highly important because that helps us define displacements, the signs of the displacements, the signs for the velocity vectors up or down. And secondly, we follow the format. We list our equations, we list our variables, and again, if we can do this right here, this is pretty much the physics of the problem, getting everything organized. And once we have this, then we have some mathematics we do, remembering to take the minus sign for velocity, which that would make sense because it's going down. Now, as long as we follow these three steps, we should be able to solve any vertical kinematics problem.